If you built a palace on a mountainside, 200 meters higher than the main river, how would you, without any modern machinery, make water defy gravity and draw it up from the river a kilometer away through underground pipes? First, you would go 6 kilometers upstream to a place much higher than the palace. There, you would build a dam to divert the river's flow into a newly dug canal. This canal would follow the rugged terrain, extending forward at a very gentle slope, eventually reaching the palace's perimeter. Now, you also need to create fountains, bathrooms with showers and underfloor heating, and a water-powered clock. Keep in mind that all of these require water pressure far greater than what the Royal Canal can provide. So to address this pressure issue, you first dig a large basin at a location higher than the palace. Water from the Royal Canal flows through an underground pipe into a well 60 meters below this basin. At the top of the well, you install a water wheel. Buckets on the water wheel, turned by mules, lift the water to the surface and fill a reservoir of about 400 cubic meters. This reservoir is located above the palace, providing the necessary water pressure for the entire system. Water from the reservoir enters the palace via a transition channel. It then splits into various waterways, supplying the right amount of water to nearby pools and fountains. You see 12 lion statues here and think, could this be made into a clock? The large bowl in the center of the fountain has 12 holes, each connected to a lion by a series of internal pipes. A central pipe fills the bowl with water at a slow, constant rate, causing the water level to gradually rise. When the water reaches a specific height, it activates one of the lion statues to spout water. The position and size of these holes are precisely calculated to ensure a stable and continuous water supply. Throughout the process, it takes 1 hour to activate the next hole. After 12 hours, the bowl will be full of water. At this point, a clever siphon system automatically resets the entire fountain. As the water level in the bowl rises, the water in the siphon also begins to rise. Once it reaches the top of the siphon, it bends and starts to fall down the drain pipe. This creates a seal, preventing air from entering to replace the falling water, thus activating the siphon effect. The surface tension of the falling water pulls the rest of the water along, rapidly emptying the bowl. Within seconds, the bowl is completely empty, and the fountain system begins to operate again. Water from the lions flows through 4 underground channels, traveling through the entire palace to the bathhouse area. The bathhouse has a cold pool, a hot room with underfloor heating, and a sauna. After entering the underground control room, the water is first heated by a copper boiler fueled by burning wood. The heated water then flows through pipes to various fountains and shower facilities around the bathhouse. Of course, floor heating. Steam from the boiler is channeled through passages beneath the marble floor. The steam rises through pillars in the steam room and is released through small vents, filling the room with water vapor. On the roof, you have also installed a series of innovative windows that can be opened and closed to control the steam level. Okay, let's continue. The water flows through the palace to the western quarters, where your soldiers live. Because this section is elevated, the water must overcome a height difference of 6 meters to reach it. Here, instead of using the previous water wheel, you've devised a special non-powered lifting device. This device works by utilizing the vortex created when water from the system flows into a container with a hole at the bottom. A low-pressure area forms at the center of the vortex, sucking air down into the container below. Here, the air and water mix to form a gas-water mixture. This mixture is then forced into a narrow pipe. Since the potential energy in both pipes is the same, under normal circumstances, the water pushing down in one pipe would equally push the water up in the other pipe. However, because the water in the narrower pipe is filled with air bubbles, it is lighter and can flow higher up the pipe. Now, through the continuous motion of the water flow in the vortex, this device can lift water 6 meters higher than its entry point, thereby supplying the required amount of water to the other parts of the palace.